Hello and welcome to our our beam deflection tutorial. Before we get started, my name is Rafa.
My name is Rogelio.
And we would like to give you a quick preview and a quick tutorial on how to use our beam deflection. First things first, we got to make sure we have our proper files. So we have our command line over here, our E, and our final folder. All you really need is this beamdeflection.m and this beamdeflection.fig, which is the figure and the script for the GUI. So now we're going to go over to this command window. So beam deflection, boom, we have our beam deflection window.
So right off the bat, you see your three graphs for deflection, shear, and moment. To the left, we have our inputs, which is a load, concentrated load P, uniform load Q, load start position A, load position end B, moment of inertia, modulus of elasticity, nodes, axial force, and the length.
We also have our simply supported button and our cantilever button. So you'll just click these once we put in all our values. So now we're going to go to our load concentrator. Let's mark this as a 10. All these values will be unitless in these cases to make things a little more simpler for the user. So we have our uniform load 0 and our start position, I'd say 5, and our end position will be 5. Since this is a concentrated load, we're gonna leave B by itself, and so B can be equal to 5 in cases of the concentrated load, only because B is arbitrary. There is no end position, just a start. The moment of inertia, we're going to put that as 85.21. You can put in any value you want, whatever you have from your chart for your beams. You have a modulus of 10 e to 10. Nodes, we'll say 30 for now. And our axial force will be 0. And our length will be 10. And we'll click simply supported.
As you can see, this is our deflection graph, our shear graph, and our moment graph. Our shear and moment graph both have a few issues, mainly this and this difference. This can be solved by increasing the number of nodes. Let's start with 100. Click on simply supported, no need to change anything. See how our graphs changed and they got more accurate. Now we're going to add 1,000 nodes and click the same button. Now our graph is as accurate as it can be. So we don't need to change values of anything, even if changing from cantilever to simply supported.
We don't even need to close out the whole window, right? We can just simply press cantilever.
Click the button, it'll do its magic.
Wow.
You get deflection, shear, and moment.
Will you look at that?
Look at that.
Woo! So now we have our cantilever. We can switch over from a concentrated load to a uniform load. So we're going to make this concentrated load a 0. We're going to move forward to our uniform. Let's make that a 10 again. So now we have a uniform load. We can extend this load since it has to be distributed along a distance of L. So we'll put it at start position of 2. It will end it at 5. Keep it there. Everything will be the same. And we can just press cantilever. And it'll still be the same. No, it will catch up. The computer needs some time to catch up. There we go. That's proper. So now we have our start distance and our end distance right here in our shear diagram. We can notice that we have a constant reaction load of 30 all the way till we get to 2, which were the start of this uniform distributed load, and it ends at 5. So it goes along as a linear slope, and it zeroes out right here once it gets past the 5, and it starts zeroing out, causing 0 constant along the moment too. We have an increase in moment from about negative 105 maybe, move all the way up to here, and we'll get our constant slope. So we can also just press simply supported, and we'll have our simply supported deflection along from 0 to 10. We also have the start position and end position notably in the shear diagram, and we have our moment diagram, which will be a parabolic function until it gets past 5, and then it becomes a linear function, constant slope, once it gets past here.
Now let's say you want your distributed load throughout the length of your beam. Well, you just set A to 0, B to 10, or your length. Click on simply supported. There's your shear, there's your moment, there's your deflection. Now do the same for cantilever. Wait for it to catch up. And there you go. Anything else I have to do?
No, all we can say is that go ahead and give this channel a subscribe. Everything I do is mostly for educational purposes, so there's no need for monetizing videos. Go ahead, give comments in the bottom. Feedback is always welcome. Thank you for listening and watching, and I hope you have a good time with this GUI. Alright, have a great time.
Goodbye.